x equals f of x, which means you'll get back the same function when you plug in negative f. You should be good with it. If it's odd, f of negative x will equal the opposite of f of x. Well, what does that look like? Okay, so the opposite of f of x is going to be a negative, and then you got x to the fourth plus 6 over 4x cubed minus 3x. Well, since we got a fraction, there's different forms that can take. Okay, so if you got like negative 1/2, that's the same as negative 1 over 2, which is the same as 1 over they're all equivalent, right? So it depends on where that negative is. So let's take a look at what happens here. F of negative x equals, everywhere there's an x, that should be a 4 there. Everywhere there's an x, you replace it with negative x, and it has to be to that power, and then you got to simplify. So 4x cubed we'll take that negative there, and then x gets replaced with negative x. Well, what is negative x to the fourth power? Anything to an even power is just going to come back as positive, right? So that's going to be x to the fourth plus 6. All right, what happens here? This whole thing becomes negative, and then this becomes positive 3x. So there's f of negative x. Well, I'm going to make the claim that this is odd. That's going to be equivalent to the opposite of f of x. How do we get there? How do we justify that? The top is the same. Okay, but what about the bottom? The bottom, both sides are different. Can I factor out a negative? Yeah, I can factor out a negative out of the bottom. X to the fourth plus 6 over negative 4x cubed minus 3x. If I put in parentheses, I'm good. So now I'm back to the original, and you can just move that to the front. And there we got our original. Because technically here you put a negative in front, you could apply it to the numerator, you could apply it to the denominator. You can't apply it to both. Okay? Or if I got a negative in the bottom, I can just move it out in front. So now that is negative f of x. So this whole thing would be odd. Like I said earlier, this tends to be the hardest one because you're not as familiar with it. But that's how you guys show it algebraically. You guys show me you plug in a negative x. You got to simplify it and see what you get. So that's the difference between even, odd, and even. All right. Homework-wise, take a look here. And I was looking at 77 and 78, and they look good for the most part. Just some minor mistakes here, easily fixable. But make sure 78 is 6x plus 3h minus 2. And for the first group there, you just had to determine whether it was even or odd using symmetry. Is it symmetric about the y-axis? If it was, then it's even. If it was symmetric about the origin, then it was odd. Because remember, you're just looking at you didn't have an equation. Okay, so even is symmetric about y-axis, and odd is symmetric about the origin. Okay, for that. Questions on any of those? All right, we're going to do 2-6 today. We're going to review tomorrow, quiz 2-1 to 2-6 on Wednesday. Okay. I passed out that first sheet, this section, and actually, I'm going to give you some guided notes in here in a minute, but that section is just, gives you what they call, it says the library of basic functions. These are all functions that you should be familiar with, or at least in some form. So a couple at the bottom you're not as familiar with. So here's what I want you to do. You take about 5 to 8 minutes. There are some common functions of algebras along with their properties, which are listed on page 257 and 258. Go ahead and open your books, 257, 258. You know, they actually give you 12. I only do the first 9. I'm not too concerned about the last 3 on 258. They don't really come up a ton. Go through there. It kind of gives you an idea how to set these up. So for that first one, okay, for that first one, they give you the graph and they list the domain, they list the range, where it's increasing, decreasing, or constant, and whether it's an even or odd function. So just kind of fill those in. Like I said, take, I don't know, 5 to 7 minutes. And then I'm going to pass out the actual guided notes for the rest of the lesson. This is just for your notebooks. There we go. All right, so those are your common functions that talk about domain, range, where it's increasing, where it's decreasing, what is symmetric about, even and odd, all that good stuff. You need to know the graphs of these functions and their properties. Well, you should know them for the most part, okay? I'm not the ones, like I said, I'm not going to ask you about like the cube root function, something that you're really not that familiar with. But the others you should be pretty well, or you should have seen before. All right, we're going to jump into the rest of that section on these guided notes. So dealing with piecewise functions, we're going to graph those, and just a little bit on linear functions as we move forward here. Let m and b be real numbers. The function f of x equals mx plus b is called a linear function. Well, that's like y equals mx plus b. That's your slope-intercept form. We just put an f of x there because we're not labeling it a function. If m equals 0, okay, so basically it just becomes f of x equals b. That is a constant function. It will be a horizontal line. For that, there is no slope to it. Slope is 0. If m equals 1 and b equals 0, the resulting function is called the identity function, which was that second one on that list where it said f of x equals x. That's your identity function. Okay. So the kind of 2 key ones there. All right. The graph of a linear function is a non-vertical line with slope m and y-intercept b. Because we're calling it a function, it cannot be vertical. Because if it was a vertical line, it would fail the vertical line test. It would not be a function. All right, just a couple of things here. If your slope is positive, and so you got your 4 little axes, just slope is positive, that means it's going to go uphill. If your slope is negative, okay, m is less than 0, it's going to go downhill. Now, we already talked about the next 2, but we're going to attach a picture to them. If it is a 0 slope or your constant function, remember, that's a horizontal line. That would be like f of x equals 4. Okay, no x with it. So just a constant, boom, all the y values are 4. If you have the identity function, goes through the origin, slope is 1, b is 0, that would be the case here. There's your identity function. And then over here, this is the constant function. So those are basically your 4 cases. Now the identity function is just another version of, it has a positive slope. Okay, it looks just the same. All right, now, says write a linear function, okay, for which f of 2 equals 4 and f of negative 3 equals negative 11. Linear function, we said, is going to be that form. F of x equals mx plus b. This is no different than finding an equation given 2 points. Well, if you think about it, f of 2 equals 4, that's going to be the point 2 comma 4. F of negative 3 equals negative 11 is negative 3 comma negative 11. I'm just going to use y minus y1 equals m times x minus x1. And I'm going to substitute my, well, what do I got to find first? I kind of skipped a half a step here. Got to find the slope. Got to find the slope, and then I pick a point and substitute those in. So for the slope, remember your slope is y2 minus y1 over x2 minus x1. Okay, negative 11 minus 4 over negative 3 minus 2. I get negative 15 over negative 5, positive 3. So there's my slope. I would pick 2, 4 every day of the week because it doesn't have any negatives. I just try to avoid those if I can. So I'm going to do m equals 3. I'll pick the point 2, 4. And so I get y minus y1, which is y minus 4, equals 3 times x minus 2. Just simplify it. Add 4. I get y equals 3x minus 2. The only thing it did say, it wants a linear function. So technically, instead of y, how do I need to label it? Take the y out, put f of x in there. So that's all we need to do. So in the end, since it's a linear function, f of x equals 3x minus 2 for that. Okay, so no different than we did before. They just give you like f of 2 or f of negative 3. All right, piecewise functions. In the definition of some functions, different rules are used for assigning different output values based upon the domain. Such functions are called piecewise functions. Okay, so you use one rule for a certain part of the domain, you use another rule. This is what it looks like. That first one's written out there for you, right? All right, f of x equals 2 if x is less than 0, and f of x equals x if x is greater than or equal to 0. You got two graphs. Okay, you got two separate graphs. 0 is a transition point. To the left of 0 is one of the graphs, including 0. To the right is a different graph. So if f of x equals 2, that's a constant function. That's a horizontal line, but that only exists for x is less than 0. Okay. You do need to go up to the point 0. You can't stop at like negative 1. You got to go all, because you got to include negative a half, negative a quarter, you got to include all those. So you put an open dot at 0, 2, and then this one is going to be a horizontal line to the left. It cannot go past that 0 because it doesn't exist there. Now the second case is f of x equals x. That's our identity function. What's its slope? Slope's 1. Okay, its y-intercept is 0. We use this for x is greater than or equal to 0. Which means when I plug in 0, I get back 0, which will be a solid dot here. It has a slope of 1. So it's going to go all the way up. It's going to look like that. All right, I'm going to give you a couple things. What is, for this function here, what's f of negative 3 equal? What's f of 4 equal? All right, make sure we understand that. What do I get when I plug in negative 3? Carlos? 2. Okay, you have to plug it into the first function. If your x value is less than 0, you automatically get back 2. What's the f of 4 equal? It's got to equal 4. Plug it into the second one. So you got to be able to identify distinct points. All right, that next one there beside it. F of x equals x squared if x is less than 2. It equals negative x plus 2 if x is greater than or equal to 2. All right, where's our transition point now? Our transition point is not 0, but it is 2. That's where things will change. So to the left of 2 will be one graph. To the right of 2 will be a second graph. So we have to graph those independently. So for the first one, f of x equals x squared. That is for x is less than 2. What I would, if you're not sure what's going on, I would do a little table. Now, you got to watch what you pick. Now, what's this graph? If it's just x squared, what's it have to look like? Or what is it if you graph the whole thing? It would be a parabola. Now, we don't know if we're graphing the whole thing. Okay, we might be, we might start at the midpoint. We might start on one edge of it. So we're going to have to do some points. Plug in 2. Even though it doesn't include 2, plug that into the equation. And when you plug in 2 into x squared, you get back 4. That'll be an open dot right there. Okay. Now I want to plug in numbers less than 2, so I'm going to plug in 1, 0, and negative 1. You want to plug in enough to make sure you get an idea what's going on with that graph. So when I plug in 1, I get back 1. When I plug in 0, and when I plug in negative 1, I get back 1. So at 2, 4, open dot. At 1, 1, everything else is a regular dot. 0, 0, 1, 1. All right, do we have enough to have an idea what's going on? Did we find the vertex? Well, you should know what x squared looks like. So yes, so it's going to go. Now, if you're not quite sure, we talked about this before, keep plotting points. But this is going to turn up. It's going to look like that. So that's your one piece. F of x equals negative x plus 2. X is greater than or equal to 2. So, is that a parabola? No, it's linear, right? How many points do you need for a linear equation? 2. You need 2. Okay. Plug in 2 again, because this one includes 2. And see what you get back. And I need to pick a number bigger than 2, so either 3 or 4 or 5. I'm just going to pick, I'm actually going to do 2, 3, and 4. Just even though I only need 2, an extra point never hurts. Do not do like negative 2, negative 1, 0, because they don't count. Only numbers bigger than or equal to 2. So if I plug in 2, negative 2 plus 2 is 0. 3, negative 3 plus 2 is negative 1. And if I plug in 4, it looks like I get negative 2. Solid dot at 2, 0 because it includes that point. So 2, 0. What do I get? 3, negative 1. 4, negative 2. Down to the right. So you get a gap in that graph, and it's okay. All right, I want you to think about this. What's f of negative 4 equal, and what's f of 5 equal? So you can figure that out. F of negative 4, f of 5. Ryan, you confident on f of negative 4?
16.
16. You plug it into the x squared. What about f of 5?
It'd be negative 3.
It'd be negative 3. Okay, so negative 3. All right, so you just got to make sure you understand which function to plug it into. You just can't do it into either one. All right, flip it over. I'm extending my scale a little bit to make this a little bit easier to draw for me. Yeah, you might be fine with where yours is at. So we'll see. All right, we got two cases. 0 is our transition point. 1 over x if x is less than 0. Negative 1/2 x squared plus 4 if x is greater than or equal to 0. Hi, 1 over x. Remember what that looks like? It's on your library of functions sheet, and it is right in the middle, the very bottom row. Okay. So 1 over x, but we're only going to do x is less than 0. So f of x equals 1 over x. X is less than 0. Include 0 in what I'm doing. So if it's less than 0, if I include 0, 1 divided by 0 is undefined. Doesn't exist there. Whoa, I don't know how to spell. Undefined. Okay, so there's no point there. But what's negative 1? What's 1 divided by negative 1? It is negative 1. What is 1 divided by negative 2? Negative 1/2. Negative 1/3. But what's happening between negative 1 and 0? So if you look at the function sheet, it exists. But think about this. What's 1 divided by negative 1/2? 1 divided by negative 1/2 will be negative 2. So here's kind of what we got. So at negative 1/2, it hits at negative 2. At negative 1, it hits at negative 1. At negative 2, negative 1/2. It's just going to keep getting closer to the x-axis as it goes to the left. And as it gets closer to 0, it's going to go vertically down that. So it's going to look like that. That's also on that sheet as well. All right, you graph the second part. See what you come up with. Think about that. And we get f of x equals, what do we got here? Negative 1/2 x squared plus 4. And that gives me, all right, so x is greater than or equal to 0. So I want to plug in numbers starting at 0. And that gives me 4. You can plug in 1 as well. It'll give me, it looks like a decimal. What happens when I plug in 2? I'm just going to plug in 2. 2 squared is 4. Negative 1/2 times 4 is negative 2 plus 4. Double check, make sure you get back 2. And then what about if I plug in 4? 4 squared is 16. That'd be negative 8 plus 4. Negative 4. All right, so I got 0, 4, which is up here. I got 2, 2, which is here. And then I got 4, negative 4, which is down here. It has to be parabola. Okay, well, it's going to be an upside down parabola. So it's going to look like that. So you got to pick points for both. You got to know what the function looks like. And then you got to pick points for both. Ooh, don't go past it. And so it does exist in zero. Okay. All right, so those are piecewise functions. Those are piecewise functions. All right, last case here. It's called the greatest integer function. All right, so, see that symbol there? Or integer. And it's, where is it on your calculator? I'm trying to think. because you can graph this. You can do the INT. So y equals, I want to see something here. Math number 5x. All right, that's the graph. It's called a stair function because it looks like what? A bunch of stairs. Looks like a bunch of stairs in terms of that. So this case, it is not connected, which is fine. Let me see something what's going on here. Okay. All right, the greatest integer less than or equal to x. So I want you to think about this. So what is f of 2 equal to? What's the biggest integer equal to or less than 2? It would be 2. What's f of 2.3 equal? What's the integer that is less than or equal to 2.3? It would be 2, right? What's f of 2.7? Be careful here. What is the integer less than or equal to 2.7? 2. You don't automatically round. What's f of 2.9? That is 2, but what's f of 3? 3. That becomes a 3. So how do we graph that? So at 2, we get back 2, and everywhere in between 2 and 3 it comes back. But here's what happens. At 3, it jumps up to where? 3. So you have to have a closed circle at 2, 2, and open circle at 3, 2. And then it jumps up to 3. And you'll get that same action. So it'll be that horizontal line all the way till you get to that whole number, then it jumps up. Okay. And then same thing here. Now we'll continue that trend. It might just be easier to go backwards here. So at 1, you get back 1. The point on the left is solid. The point on the right is open. Okay, this isn't always obvious, but I want you to think, what is f of negative 1.3? F of negative 1.3. Okay, what integer is less than or equal to negative 1.3? Carlos? Negative 2, because what's smaller than it? It'd be negative 2. Now make sure that matches up. So if I go to negative 1.3, that does hit at negative 2. A lot of times your first instinct is to go to negative 1, okay, because with the negatives. So you got to remember, smaller than negative 1.3 would actually be negative 2. Okay. F of negative 3.4 would be negative 4. All right, for that. So that is called a step function. We saw the graph. Okay. It looks like a bunch of stairs going up. Now you can't see the hollow and the open dots at this point. Okay. All right. 259 to 260. Ooh, 5 problems. Solved. We'll review tomorrow. Okay, this is it for the new material. We'll review tomorrow, and we'll have a quiz on Wednesday.